Today we are talking about 7-1 oblique triangles and the law of sines. So, what in the world is an oblique triangle? Did you?
It has nothing the same.
Well, that can be the case. But if you look right here, it tells us it's any triangle that's not a right triangle. So these could be acute or obtuse, it doesn't matter. So we're going to call those oblique. So, hopefully you remember from way back when in geometry, if you had two triangles and you want to prove to me that they were congruent, one way to prove two shapes are congruent is to verify that all of the sides and all of the angles are the same. That's a lot of work though with a triangle because that's 6 bits of information. You'd have to verify all 3 sides and all 3 angles. With triangles, we had these 5 shortcuts. Instead of showing me 6 things, you can show me just 3. So, you had 2 sides and an angle in between them the same. So then, even without measuring, automatically the 3rd side will be congruent, and the other 2 angles would be. You could have also done 2 angles with the side in between them. You could have done 2 angles with the side on the not in between them. Or you could have done side, side, side. Alright, there is one more, but that refers to right triangles, and we're not talking about right triangles here, but just so we remember, what was the one way that was for right triangles only?
Isn't it right hypotenuse?
Close. Hypotenuse leg. Remember that? HL? Right triangles only. So anyway, you can prove 2 triangles were congruent using one of these methods. Alright, so we're going to use this idea with our oblique triangle. Alright, so if I want to find, well, let's just recap. Remember how in a triangle we label each of the corners with a capital letter? So that's capital A. This is supposed to be capital B. It's a little shifted. And this thing is capital C. And then remember that across from those angles are the lowercase of each letter. So there's lowercase c across from big C. Here's capital A, so there would be side lowercase a. Remember how this works? So this is standard all over the place. So make sure that you're paying attention to whether a letter is capital or not, because it matters. Capital letter would refer to an angle, lowercase would refer to a side. Alright, so check out the law of sines, which is super handy and easy to remember too. Turns out if you take the side length across from angle A and divide it by the sine of that same angle, it's equal to the ratio of doing it between any of the other 2 sides. Let's try it.
Do an example.
Okay. So let's take a triangle that we know. How about a 45, 45, 90 triangle? Because we know all those pieces, right? 45, 45, 90. And let's just say if this is 5, and then what's this? Oh, you're doing way too much work.
Isn't it the root of 5?
5 root 2. Remember special right triangles? Okay, so according to the law of sines, if I take any side and I divide it by the sine of that angle that it's across from, it's going to be equal to any of the other ones. Okay.
Isn't the sine of 90 0 though?
Well, so, oh, right, we're not supposed to use right triangles. Crap. Dang it. No, I didn't think it through.
What about a 4, 5, or 3, 4, 5 triangle?
It's still a right triangle.
It is? Man, I don't know my triangles. Not if I get above a 60.
I need a protractor.
I got you. Where are they?
I got it.
Yo. We should be fishing.
What? I know. I'd make it. Oh, yeah, no, I'm saying. Right, like what?
We could go do all those things you just said. I knew it.
But at the same time, it's a beautiful day.
2.
Savia, is the test reader still gonna be on progress reports?
No.
Alright.
Okay, so this is obviously not going to be perfect because I just sketched this by hand and my measurements are almost, they're as accurate as I can make them. But this side's 1 inch, 2 inches, and this is about 1.5 inches. And then these angles are approximately 44 and 110. So
Angle, right? Or you need to.
you can find the third angle if you feel like it.
What is it?
What?
What is it, 10?
26.
Might as well put it as a
All right. So, law of sines tells me I can take any one of the 3 sides. Pick one.
A.
Well,
1.5.
1.5. I can divide it by the sine of the angle across from it, which would be,
1.
no, the angle, 44.
Well, it's more so down to the left, not straight across.
Opposite, I should be saying. And that will be equal to, pick another side,
2 and 110.
2 and sine of 110. So I will check this on the calculator and see. They obviously, again, I'm doing this by hand. These are not exact measurements, but they're going to be pretty gosh darn close. So first, yes, let's make sure that we are in what mode should I be in? Degrees, thank you. So if I do 1.5 divided by the sine of 44, it comes out to be, what? Hold on. 1.5 divided by a sine of 44. There we go, okay. Approximately 2.159, all right? So I'm expecting to get pretty gosh darn close to the same thing over here. 2 divided by the sine of 110. Well, what do you know? I get 2.13.
That's not.
Oh my God, guys, how many times do I have to tell you? I can only measure so precise on this, right? Right? I can only measure to the nearest whole degree. This is not perfect. I said it 10,000 times. Yes, I'm making the triangle as best I can. So I said to you, these are going to be awfully close to each other, but they may not be perfect because I'm doing it by hand. They're awfully close to each other, but they are not perfect because I did it by hand. Holy moly. Anyway, whew. So your law of sines is particularly useful to solve for any piece of an oblique triangle that you may need. So let's try example number 1. We need to solve triangle ABC given this criteria. So I'm just going to draw myself a triangle ABC. What's the matter?
Why? How are we gonna figure that? Oh no, never mind. 25.3 inches. Sorry.
Okay. In order to make it a little bit more accurate, I'll relabel my triangle this way. Angle A is approximately 28.8. Well, it's not approximately, it is. C is 102.6. And lowercase c is 25.3. So that, make sure you are putting it opposite angle C, 25.3. Exactly. I'm supposed to solve this triangle. What does that mean?
Figure out what each side is.
You have to find all the angles and all the sides. You can find the missing angle right now very easily.
Yep.
So let's do that. 180 minus 102.6 minus 28.8. The third angle would be 48.6. Great. Now I just need to figure out these 2 sides.
I know how you do that.
Great. Tell me.
You go 25.3 over sine of 102.6 is equivalent to x over
Whatever one you want.
sine of 28.8.
So let's call little a over sine 28.8. Perfect. Doing this math out now will give me an answer for little a, so I'll be able to find the length of this side. We've only been able to do this with right triangles up until now. But using the law of sines, now I don't need a right triangle. So, 20, go ahead and solve this, everybody. You should all have a calculator. If you don't, you're going to need to grab one.
I got one, Zach. Let me try. 21, 23.
There's only the bad count. There's one right there.
There's another yellow one right there.
It's a big one.
Oh. Alright.
Who's got an answer?
Not yet.
Don't you gotta cross?
Cross multiply? No?
I would.
Yeah, me too.
I would. Alright, well, let me restart then.
Because how else would you?
What place do we round to?
You tell me. You already know.
100?
If you know they're gonna be equal, then you just do 25.3 divided by that. And then that number times 28.8.
You could do that.
Can you just cross multiply it?
I did. I multiplied this times this divided by that.
That's what I was gonna do.
Wait, you said
I should just teach.
I got 12.
Same. 12.489.
And what place would we round to?
I'd go 10.
Well, it's
Wait, no,
25.3,
those have
so
to be
you go to
something,
10.
The whole problem, they go
significant figures.
12.5.
So you already know.
It's 12.5.
Right. The least amount of sig figs I have in this is 3, so I should go to the, I should have 3 in my answer, 12.5. Now, that's only side A. I also need side B, so now I have this one.
Can you show the process of cross multiplying?
This isn't a right triangle.
Like you just do 25 times.
Yeah, remember you multiply your diagonals? Set them equal to each other. And then, yes, I will show you. Multiply 25.3 times sine of 28.8. And that equals A times sine 102.6. Right? But then to get A by itself, when I just divide both sides by sine of 102.6.
What do you divide them both by?
This. I'm solving for A, so divide by sine of 102.6.
Okay.
So your fast way to do it is just multiply these diagonals and divide by that one. Okay, when you go to find B, please, guys, listen. Try and avoid using this number if you can. Because A, what if you got it wrong? And B, it is a rounded number. So if you use a rounded number to get your next number, it's going to be that much further off. So you only use an answer that you got if you absolutely have to. But there's a way to not. If I'm trying to find little b, couldn't I do little b over sine 48.6? And what would that be equal to if I'm trying to avoid using this number? What could I set it equal to?
You're not trying to use that. Oh, wait.
I don't want to use 12.5. Can I just use these two again? Sure. I know they're not wrong because that's what they gave me. That's the given information. Always try to avoid using an answer you got to get the next answer. Okay, who's got a value for B? Wow.
One second.
Don't get angry, God. Can I just do sign up for me?
No, cause that wouldn't, like, that wouldn't.
Is it 19.44?
Yep.
Or is it, wait, 19.4?
4.
Yes.
I got 19.06.
Above.
Double check. So, a really quick thing to do to check, remember another little nugget from geometry.
19.4. Yeah.
Across from the biggest angle is the biggest side. Across from the smallest angle is the small side. So when I check this real quick and I find out that B is 19.4, I should just verify, yep, smallest side is still crossing the smallest angle, middle side, middle angle, biggest side, biggest angle. It's just a nice, it doesn't guarantee me that they're right, but at least I know I'm not totally wrong.
Is this just like the intro? Or is this actually like semifinal?
Is
Does
it
get
what?
harder than this?
Well, we just add on to it.
It does.
Let's try example 2.
Oh no, there's no picture.
So this one's a little bit different. I will give you, I don't know, 3 minutes to solve this triangle.
What?
You know we're all gonna fail.
I have faith.
So, wait.
So if we get A and B on the, whenever we have like a quiz or test on this, do you want us to still use the sine rule to find C, or can we just use the Pythagorean?
You can't use the Pythagorean theorem.
It's not
Oh,
right.
wait.
Because it's not a right triangle. I tried to do that too.
I'll give you 30 more seconds. You should be almost done. All right. So, first thing I did was find missing angle B, because you have to find it anyway.
It's 34.
Yes. So now, since I have one pair, a side and its angle, I can find anything else. So if I do B, B, which is 75.6 over sine of 34, I can find either A or C next. I'll find A. Little a over sine of 28.8. So I just do this math and I will solve for side A, and I get 65.1. Did you all get 65.1 for A? You may not have solved it exactly the way that I did, but that's fine. And then I did the same thing, but I'm going to solve now for C. And again, I would start off with 75.6 over sine of 34. I would not use the answer I just got for A to get me my answer for C, because what if it's wrong? And even if it's not wrong, it is rounded. So there is a proportion that will solve for C. So you should have gotten C to be approximately 120.2. Did you? Oh, good. We're in feet, so these are feet.
What was A again?
65.1.
Sick,
Wait, why did you make C 4
I was just thinking about lunch.
Oh, I don't know.
Laugh right.
You read it should be 3, so I should be calling it just 120.
Lose it, man. First Friday, we gotta get you like. I'm doing something wrong with my multiplication.
Are you in degrees?
Oh, that. Yeah.
You are? So if you're going to find A, for example, did you do 75.6 times sine of 28.8? Do it again right now and tell me what you get for just that. 75.6 times sine of 28.8.
34.42.
No. Are you sure you're in degrees?
I'm in degrees.
Are you dividing afterwards?
75.6 times sine 28.8.
You didn't get this
My
one?
calculator, it comes up. I just said 36.4.
I thought you said something else.
Oh, no.
Sorry. Okay, that's on me then. Now, just divide that answer. Divide by sine of 34.
Oh, well, thank you.
Okay. All right. Let's try example 3. Let's see. Try and draw the diagram without me telling you how to do it. Bearing of a lighthouse from a ship, north 52 west. The ship is going to sail 5.8 kilometers due south. New bearing is north 23 west. Find these distances. So, don't try and solve anything yet. Just draw yourself the diagram. See if you can figure out how to draw the diagram without me doing it.
I'm gonna draw like a compass. North, east, west. 52 degrees. Let's go right here. And then it sailed.
No, there's a kicker from LSU, I mean from something that went to LSU. That, played for him.
This kid got drafted.
That's pretty good.
And I don't know how good he is. I bet he wants to the field. But it's still,
Matter.
it's still being drafted. Yeah, Gloria might end up in the Saints.
Okay, did you sketch it?
I don't know. I don't even know where the first line.
Oh, golly.
I drew a straight line.
All right.
I have a straight line.
The bearing of a lighthouse from a ship. So, this means that you need to have a ship. All right, so there's my ship. And it says that the lighthouse from the ship, right, the lighthouse is going to be north, 52 west. So here's my ship, north direction. So in fact, I'll draw a north-south line between the ship. And then I want to be 52 degrees in the west direction. So somewhere about here-ish is going to be my lighthouse.
And then you just go down.
I thought it was west.
It is, that's west.
Oh, yeah.
North direction
So stupid.
on the west side. So this angle right here is 52. That's what that tells you. So the bearing of a lighthouse from a ship was found to be north 52 west. Ship, lighthouse, north 52 degrees in the west direction. After the ship has sailed 5.8 kilometers due south,
So just straight down.
straight down, that's where the ship was. Now it's going to sail 5.8 kilometers straight down.
And guess what? You got yourself a triangle.
Now, my ship is now here, and now they're telling you, now, after it has sailed, the new bearing from the ship to the lighthouse is north, so still in the north direction, 23 degrees in the west direction. So when I draw this, it's telling me that this is 23 degrees. North direction, 23 degrees towards the west.
So that 52 degrees is.
Would it be alternate interiors or?
Well, no, I don't have any parallel lines, but I do know this angle.
How?
23.
Is it 180 minus 52?
Yes, this is just a straight line. That's my north-south line. If that's 52, this is 180 minus 52, or 128.
It's gonna be, I don't know, what is that? Yeah, I mean, 128.
Yes. So now I have, let's see, and if I know two angles, I know the third one,
How do you know that's 128?
because this is a straight line. You already have 52. These two together have to get me to 180. So my last angle will be 29.
Plus 128, 131, minus 180 is 29.
So now, what do they want? Find the distance to the nearest tenth between the ship and the lighthouse at each location. So when the ship was here, the distance from the ship to the lighthouse,
Just find the side.
right. So I have to find that side, I'll call it X, and then I also need to find the distance between the ship and the lighthouse after it's sailed. I'll call that side Y. So I have to find X and Y. I'm going to use this law of sines. I already have one pair, right? Angle 29, and the side across from it is 5.8. So that's the pair I'm going to use to find the others. So I might do something like 5.8 over the sine of 29 equals, how about X over the sine of 23?
Could you just use A or something?
That doesn't matter. You can use A, B. I just always go to X's and Y's, but you can do whatever you like. I agree. Then I do the same thing again. Just going to set up for Y instead.
What is it? X is
X was 4.7. And then I'm just doing the same thing to solve for Y. Did you guys get 9.4 for your other side?
Yep.
So, using the law of sines is pretty easy as long as you know it.
What was the next one?
Y was 9.4. Or your other side, anyway.
Ooh, the area.
Don't forget, you can do the really quick check that across from the biggest angle is the biggest side. So that makes sense that Y is a much bigger number than the other two. Right? And then 23 was the smallest. 4.7 would be my small side. All right. Okay, now, what if I asked you to find the area of a triangle like the one in this picture?
Find all your values then.
So it would have been really annoying if you were just using 1/2 base times height, right? Because you have the base, you'd have to somehow figure out what the height is in there, because the base and the height have to be perpendicular to each other. So in a right triangle, it's not that big of a deal because two sides are always going to be perpendicular. But when they're not right triangles, it's really kind of annoying. Lucky for you, there's another formula that doesn't require you to have perpendicular sides. And it's right here. 1/2 BC times the sine of A. So really all this is, B and C are just two sides of the triangle. So if I know two sides of the triangle, it really doesn't even matter which two sides they are. Just two sides.
Does that have to be one and the hypotenuse?
There's no hypotenuse. I don't have right triangles.
Yeah, you do the biggest side.
Only in a right triangle it's called that though.
Really?
So what's it called in other
What's the big
triangles?
side called?
Biggest side.
Yeah, I just learned something.
That's kind of silly.
Any Hoosers, so I have two sides of a triangle. Here's what you need. I'm not even going to look at this diagram. Let's just say I had two sides. Let's say I knew this side was 10, this side was 11. If I want the area of this triangle, I can find it if as long as I know the measure of the angle in between those two sides. That's what I need. So I would need to know the measure of this angle right here. So let's say that angle is, I don't know, 20 degrees. If that's all the information I have, I can get the area of this triangle. 1/2 B times C, just any two sides of the triangle, times the sine of A. A just has to be the angle in between the two sides that you're using. That's all it is. So don't get hung up on the letters that you have to have A and you have to have B and you have to... No. B and C are just any two sides. Angle A is the side in between those two sides. It's the angle in between the two sides that you're going to use. So literally, the area of this triangle, think of all the work you would have to do. You could do it 1/2 base times height. You could figure out this height if you created a right triangle, then did all this hard math stuff. You don't have to anymore. 1/2 BC times the sine of A. So the area of this triangle is 1/2 times 10 times 11 times the sine of 20.
Why didn't they tell us that in geometry?
Depends. I told my kids in geometry. I
No,
did.
Either you didn't or I didn't learn that because this is the first I'm hearing about this.
You learned it. It goes in one ear out the other because we do it at the end really fast. You learned it.
It was over a year ago.
It's okay. That's why we do it again. And now it'll stick because you'll be like, oh, this is so convenient. So, take a look at example 4. Just sketch yourself a little triangle, doesn't even really matter. Two sides are, okay, they want A, B, C. So, C, little c is 9. Little b is 12. Oh. I almost put it in the wrong spot. And then angle A is 127. So, I have all the pieces I need. I'm literally just doing 1/2 B times C times sine of A. That's it. 0.5 times 12 times 9 times sine 127. 43.1.
Where'd you get
But
1/2?
isn't that too many sig figs?
Oh, Oh, never mind. That's part
Oh,
of it.
yeah, there's only two. 43, yep. What are my units if I'm talking area? Feet squared. That's it. That's it, guys. So, this area formula is super convenient. Let's see if it's on your reference sheet. I think it is. But let's check. Well, look at this. It is on your reference sheet. Now, they just give it to you all three different ways. Whatever. I don't even, it's silly to have it different ways. As long as you know B and C are any two sides, and angle A has to be the angle in between sides B and C. You're golden. So, there it is, area of a triangle. Law of sines is also up here. So, even though that's super easy, it's still there for you. So, that's great. All right, so try 4. Sure, whatever you gotta do. Everybody try example 4.
Oh, wait, we don't have sine angles, so we have, oh wait, we can find sine angles.
What?
We have angle, side angle.
We're gonna be able to find sine angles.
What are you talking about?
For example 4.
You're gonna find the area of that triangle. You have two sides. You have
Sine
Where's
angle
the second
side
side?
formula, right?
oh, sorry, no, you have two angles.
Yeah.
Oh, fun. Maybe you'll have to do a little bit of law of sines first.
A little bit of extra steps.
Maybe.
Yeah, okay. Exactly.
Good.
I don't like the degrees part. Degrees minutes.
You stick with this, divide by six.
What was the area of the first one? Like the first one?
43.
Proud of you, man.
Thanks. You know, I wasn't gonna, and I was like, you know what? I'll get it.
Straight up. You know, it's supposed to be like. I'm supposed to do it. If you want.
Thanks, man.
Sure.
Why do you use degrees and minutes? Just say it, who's Jared the seal?
I don't know.
He's their mascot. Can't you read?
Oh, Jared the Seal. I thought you said the Seal,
Hey,
like a person's name.
Jared the.
He is A Block's mascot.
why don't we get a mascot?
You have the cat on the back.
That's not us.
It is now.
What happened to the other cat?
Yeah.
You know, if you look at it.
This is cat number 2.
What happened
Cat
to
number
cat
1 was better.
We don't want to talk about it.
yeah.
He didn't kill like 90% of their animals. Like, he did.
I kill 90% of animals that I see.
Even humans?
But
Humans are the most dangerous kind of
have no idea.
I'm gonna look it up right now. I feel like it was.
What an awful question.
What, do the book was written by?
Yes.
Did you really expect the math teacher?
No, it's Richard Connell.
You didn't know it's
He's a
called-
biology teacher.
Oh, that must mean he knows everything.
I mean,
Sadie is a biology teacher.
Well,
Was.
it's gonna be a biology.
Actually, you know what? I never made it to biology. I did chemistry and physics.
why don't you teach us biology?
I don't remember any of it.
I don't think so.
Dude, if you yell out the answer before I actually stumble upon it myself.
I'm almost there. Please do not say anything.
16. You don't think I couldn't get it moving fast? Not scary, bro. Timmy.
Hey, just like Chase.
Yeah. I'll run it up. I got
I actually typed it wrong.
You got 48, 20?
For that angle, yes.
You got 48.3.
That's in decimal.
That's in the count.
It's the same thing.
Can we just leave it as a decimal?
I don't care.
You can just hit degrees in a second so it's converted by.
Oh my god, you're right. I actually don't know how to get that.
That's why
Go
I'm
second PRB
I got it.
instead of like PBR.
Yeah.
PRB.
40.
This kid. I never should have.
Nuts. Wow. 48 degrees, 19 seconds. Minutes. Minutes. Seconds.
Yeah.
Oh yeah. Man, I don't actually know if it's right, but I got a good idea.
For the area? Oh, I could probably get cast
Oh, Miss Sabia, did we have to use 73 degrees 30? And I think I used the wrong angle, which is why I got the wrong area. Like I did 48 and 58, so I did it wrong.
Did you solve for this side?
I'll show you.
It's not wrong if you did that.
I got it. It's like when there's a setup, I think I set it up wrong.
This is, yeah, that's wrong.
Should be under 70, 3 point.
No, it's always the side and then the angle opposite it.
So it should have been 40,
Yeah, that should have been signed 43.3.
no, 48.3. I just wrote it wrong. It should be
Oh,
48,
okay.
because the angle's 48.
Okay, and then this side, if you're gonna solve for B, so you have this side over sine of that equals B over sine of that, right? Because it's always the side with the angle across from it. That's who goes on top and bottom. You're welcome.
Is this right? Close to it.
I'm at 576, so we'll go with yeah. That sounds good.
Did I do like a arithmetic or anything?
Did you solve for side? Let me see.
Sadie, it's gonna be an hour and a half long video.
2.5. Yeah. Sure. You did way more work than you had to. Once you had, they gave you this side, and then you just need to solve for one of these two sides. You don't need them both.
Why?
Because once you have one of them, can't you do 1/2 this times the sine of this? You never need this side. Or you could do 1/2 this times sine of this, and you don't need this side.
Oh, okay.
But, so which one did you do? Oh, you did this,
Yeah, I did that.
sine of that?
Yeah.
Okay, that should